So we already know that the derivative of e to the x is also e to the x. In this video, we want to look at how to prove it by using the formal definition of derivative. First, let's write down the definition of derivative. The derivative at point A is going to be equal to the limit as h goes to 0, f of a plus h minus f of a divided by h. Where on the top, we have the change in function value. And on the bottom h, we have h stands for a very small change. And on the bottom we have h, where h here stands for a very small change in x. So the derivative of a function at that point basically measures the rate of change at that point. So let's plug into our original equation e to the x. Since we're calculating the derivative of e to the x and not at a specific point, we'll say the derivative of f of x is equal to the limit as h goes to 0, e to the x plus h minus e to the x over h. So again, on the top part, we have the change in function value, and bottom we have h, which stands for a small change in x. And to simplify this, we would use the equation that e to the x plus h is equal to e to the x times e to the h. Okay, now we can combine the terms. Then the next step, we can get the limit as h goes to 0. We have e to the x times e to the h minus e to the x over h. And the top part, we can take e to the x out, which gave us e to the x times the limit as h goes to 0, e to the h minus 1 over h. Then our question becomes how to calculate the limit of this part. If it's a separate question, then you can probably use L'Hopital's rules because you have a 0 over 0 case. But since here we want to prove by definition the derivative of e to the x, we'll try a different method. Let's use the Taylor expansion for e to the h function. So the Taylor series for e to the h around h equal to 0 is e to the h is equal to 1 plus h squared over 2 factor plus h to the third over 3 factor, etc. And subtract 1, we get, let me just moved 1 to the other side, we would get e to the h minus 1 is equal to all of these on the right side. And let's divide it by h. We would get e to the h minus 1 over h. That's equal to 1 plus h over 2 factor plus h to the second over 3 factor plus. So as h approaches 0, all of these, all the higher terms, will goes to 0. So all these parts will disappear, which leave us what we want to calculate is e to the h minus 1, which leaves us e to the h minus 1 over h is equal to 1. And now we plug in the answer into our original equation. We would get e to the x, the derivative of that. By definition, we get e to the x times 1, because the limit of all this is equal to 1. Then we have proved that the derivative of e to the x is also e to the x.